Good day, math students. Today we're going to look at a special situation with the law of signs. It's called the ambiguous case. And to start us off, I've got a little drawing here. And let's say you were given this information where you know this side is 8 and this side over here is 6, and then the angle across from it is 42 degrees. So I'd look at this and I go, hey, yeah, that looks pretty good. But wait a minute, couldn't I have drawn this 6 over here like this? Couldn't I have drawn it so it's down this way? I mean, who says it goes like this? How do you know? I mean, everything else would fit, even if I drew it like this. I mean, this side would be 8, this side would be 6, and this angle would be 42 degrees. And that's the ambiguous case. Which one is it? So when you have the ambiguous case, there are two possible triangles that could occur. So two possible triangles. So really, it's not that big a deal. All you got to do is accept that if you run into this, there are going to be two groups of answers. There's going to be an answer for the bigger triangle, and there's going to be a set of answers for the little triangle here. Now here's the key to the whole thing. The key to the whole thing is that this angle here is the same as this angle here, and that's because this is an isosceles triangle. That's the key to the whole thing. So when we figure out the angle down here, we also know this angle over here, which means we also know this angle here. So that's how you unravel this thing. Let me just show you one other thing before we actually do an example. It's a kind of way I like to visualize the law of signs with the ambiguous case, and I call it the fishing rod analogy. So imagine this. Suppose you had a fishing rod and you're holding it like this. Okay? So we know this length. Okay? The length of how big the fishing rod is. And then somebody says, we want to make an angle here with the horizontal or wherever. We want to make an angle down here. So what we know is we know this angle. Now we don't know how far this line goes, okay? Because that's not the length that we know. We know this angle, and we know the length of the fishing rod. And the other thing is, what we're told is this length over here. And that's the length of line that you let out. So basically, if your length of line is long enough, it can either go here like this, or it could go here like this. Okay, so I like to think of it as a kind of fishing rod where you know the length of line, you know the length of the rod, and you know the angle that you're holding the rod at. Okay, that's my little fishing rod analogy, and that's for those situations where there's no picture and you kind of got to draw it yourself. So that's going to lead me actually to my first example. Okay, suppose they tell us, actually my first example is the one that was up before, but let's just say they didn't have the picture provided. Say they just tell you this. You go, okay, our angle A is 42 degrees, side AB is 8, and side BC is 6. If I was going to go draw this now, I'd go, okay, well let's run a horizontal line, and let's build up angle A. So we build up angle A somewhere up to there, okay? So I just go, yeah, that's angle A. That's 42 degrees. And I know that somewhere across here is the side A. Oh, no, that's not AB. BC, right? Because somewhere here, let's say that's B, and that's C. So there's BC. So let's just finish our little triangle here. So there's BC. And I know the length of BC is 6. And then I know AB is 8. So you kind of build your little triangle, and it makes it much easier, I think, thinking of the fishing rod stuff. Now, to make this easier, I'm going to call this C1. And when we put in the extra line down here, I'm going to call this guy C2. Okay? But let's say I didn't know about this here. and I only knew about, okay, I drew my triangle, I forgot about the ambiguous case. Is it such a big deal? Well, no, not really. I can get a lot of this done without it. So I'm going to start off with the law of sines and say sine of 42 degrees and divide that by the side across from it, which is 6. And that's going to be true for the sine of angle C. Now, let's say I just didn't know there was any kind of possibility, so I'm just going to call it C1 divided by 8. Okay, so I go through and I do my cross multiply and divide. And then, of course, in this case, I have to do a sine inverse. So let's say I did all that. If I did that, then angle C1 turns out to be 63 degrees. And you can see that matches this drawing perfectly. Okay. Now, if I were to continue and say, okay, well, let's say I just didn't suspect another triangle. So I'm going to find, well, what would angle B be in that case? Well, remember, you got the big triangle here, and you know this is 42 degrees, and this one's 63. So I would just go, well, they have to add up to 180. So let's take away these other two angles that we know, and that leaves us with 75 degrees. So I go, yep, got it. So the only thing that I don't have is side B, and that's from A all the way over to C1, the big side here. How am I going to get that? You guessed it, law of sines. So I go sine of 42 over 6, and that has to equal the sine of angle B, and I just worked out angle B is 75 degrees, divided by the side across from it, which is the long side there. So now I would cross multiply and divide, so 6 times sine of 75 degrees divided by sine of 42, and that's going to give me the following. Okay, I got for B, it is 8.66. Okay, so I was able to solve this outer triangle without even realizing that there is a second triangle possible. So, you know, I got half the job done, and that's not too bad. Now, let's say I got to finish the job. And this is where experience comes in, and you go, yes, I know there's another possibility. I know this angle here would be 63 degrees. So is it possible to have this other little triangle? Well, let's have a little look. What would angle C2 be? Well, since it's supplementary to the 63 degrees, I'm going to go 180 minus 63. And that turns out to be 117 degrees. Okay? Now, if it's going to work, then this other angle B has to exist too. So let's figure it out. So let's go 180 minus this new angle C, and minus also the 42 degrees for angle A. So is this going to work? Yes, it does. We actually get a 21 degree angle up there. So that's working. And now I'm going to do the same thing that I did down here. I'm going to use the law of sines to figure out the length of side B. So I go sine of 42 degrees divided by 6. That has to equal the sine of this new angle B, which is 21, divided by the side across. Again, I cross multiply and divide, and guess what? I get my answer. So this one is, of course, much shorter. So it is 3.21. So this ambiguous case is not such a big deal. You just got to think of setting up your fishing rod with the angle and then letting out a certain amount of line and seeing if you can draw it two different ways. And then you'll get your two sets of answers. All right, I'm going to stop there. We'll come back with another example.